Hello and happy Tuesday. Hope you're doing really well. And we've been talking a lot about acids and bases in this chapter. And I just want to go over some more of the math associated with this. And do not, I repeat, do not freak out on me because it's very easy math. I promise. It sounds like it's just terrible and hard, but it's not. Okay, it's something that you can actually learn to look at and do without a calculator. I'm going to show you how to do it on the calculator, but we're doing some really simple things that you really won't need your calculator for even. And so before we get into the math behind pH and pOH, I want to remind you that the way that we consider something an acid is if it donates hydrogen ions when it's in solution. And so a hydrogen ion is basically a hydrogen atom that has lost its electron. Remember, a hydrogen ion usually has one proton, one electron. If it loses it, it becomes positive because it lost a negative charge. And if you mix this hydrogen atom with water, which is H2O, you're going to get what we call hydronium, which is H3O+. And so remember, the water was H2O, and if you add an H plus the H2O, instead of H2O, you added another hydrogen, so it's H3, and then it had a positive charge from here, and so it becomes hydronium. So when we write it out, this is a hydronium ion. And so acids are going to produce hydronium ions in solution. And so instead of just saying something is an acid or something's a base or something's neutral, we can actually assign a numerical value to it. And SPL Sorensen came up with the idea of doing this by using pH values. And I hope you enjoyed the video, the crash course video for chemistry yesterday. It's kind of interesting that when we look at pH, I have it written down here for something else, but when we look at pH, no one's really super sure what the lowercase p means. There have been some good guesses, but he didn't actually document that. I guess he was so busy talking about it that he didn't say what the p meant. But basically it tells us the amount of hydrogen ion concentrations in a solution, or hydronium ion concentrations in a solution, because they become much the same. Like whatever hydrogen ions are made, they're gonna combine with the water to make hydronium. So we usually just say hydronium ion concentrations when we're talking about acids. And so his little thing was that he came up with this idea that pH, which is usually a number from 0 to 14, is equal to the negative log of the hydronium ion concentration. The hydronium ion concentration is typically something really small. Like, for example, it might be 10 to the negative 8, like that. So that's a really small number. And if you want to get technical, it should really be 1 times 10 to the negative 8. And a lot of people don't deal well with numbers like that. Like your grandma is not going to understand that. So this is a great way to use a simple thing on the calculator, and it really doesn't have much to do with logarithms. It's just the fact that the log can turn it into a reasonable number. And so if you really go on here, and you have a log key on your calculator right here. See it? Yes. Okay, so if I if I want to figure out the pH, if the hydronium ion concentration is 1 times 10 to the negative 8, I would need to do the negative log. So I'm going to do negative, and then I'm just going to hit the log key, and then I lost it for a second. There it is. So when I do that, it just bumps up a thing. It almost looks like I'm about to do the square root. Okay, but I don't need to put in 1 times 10 to the negative 8. I'm just going to do 10 to the negative 8. So I'm going to use my little caret key. And then I'm going to close that parenthesis, so that's what it's looking like there. And then when I press enter, 8. And so if the hydronium ion concentration is 1 times 10 to the negative 8, or 10 to the negative 8, it's got a pH of 8. Good. All right, so the pH here would be equal to 8. Okay, what if we had like a hydronium ion concentration of 1 times 10 to the negative 10. I bet you can guess what it would be. I'm going to go ahead and show you though for sure. So if I do, remember I have to do negative log. So I'm going to hit the negative button, not the minus button. And then I'm going to do 10 exponent negative 10. Okay, and then let's see what it comes up as. Oh, look, it's 10. Okay, do you see a pattern here? Yes. Whatever the negative exponent is for the power of the hydronium ion concentration, that's the pH. And so we're going to give you some very simple ones in this chemistry class that you can just look at. And if it's like 10 to the negative 6, it's going to have a pH of 6. And so that's pretty easy for you to work through, hopefully. Now, if you take chemistry in college, expect that they might actually give some that you would have to work out in your calculator. So like I said, do not freak out. It's not hard. Just like whatever the negative exponent is, if it's like 10 to the negative 3, it's going to be a pH of 3. So you can do that. All right, so another thing to think about is the fact that the pH plus the pOH is always equal to 14. Okay, so the pH is a measure of the hydronium ion concentration. The pOH is a measure of hydroxide ion concentration. And if you remember from other sections, acids have a low value for this, and bases are going to have actually a high value for the pH, like closer to 14. But whenever we have any solution, it can have both a pH and a pOH. And so if it's got a low value for this, for the pH, it's going to have a high value for that, so that they always equal to 14. And so if I tell you the value of a pOH concentration, if I say that the concentration of the hydroxide ion is like 1 times 10 to the negative 2, if I say that, then I can figure out the pOH. And it's the same way. If it's 1 times 10 to the negative 2, the pOH is going to be 2. And so if I know that the pOH is 2, and I know that the pH plus the pOH is going to equal 14, I can figure out the pH. Okay, so if I know that whatever the pH is plus 2 is going to be equal to 14, guess what the pH is for this? It's going to be 12. And so the pH, I'm going to do it in a different color marker. It's going to be 12 like that. Let's do one more like that. You really just have to figure out, am I talking about the concentration of hydroxide or hydronium? Hydronium is going to be associated with pH. The concentration of hydroxide, OH negative, is going to be associated with pOH. And so if I say that the concentration of hydroxide is 1 times 10 to the, let's do negative 9th this time. So if I say that, then my pOH is going to be equal to 9. Okay, and then if I figure out the pH, really it's just going to be 14 minus 9, okay, which is 5. So the pH is equal to 5. Nice. And that's a little bit sloppy writing. Sorry about that. Okay, but that's how we do the math behind this. And so answer a few questions at the link provided. And then we'll be wrapping up this chapter very soon. I think we'll do questions today, quiz tomorrow, and then we'll just go ahead and take a test on chapter 14 very soon. So look for that. Y'all are doing great. Please keep doing your work. I'm so proud. There are some of you who have never missed an assignment, and you're doing it so faithfully, and I appreciate that so much. Keep up the hard work, and email me if you have any questions. You can always send me a message, and I will respond. And I hope you're doing well, and I hope your family is doing well also.